All right, students, for those of you that were not able to make it to class on the 19th, I wanted to make a short little video about what happened during class so that you can come in next week and know exactly what's going on, and so you know what your distance learning task is. So, the first thing to know is that we talked a little bit about last class, um, and I added the video that I wanted you to watch from Physics Girls Introduction to Physics. And that is in your Google Classroom. And then I also talked a little bit about why we did all the questions with the cameras and watched those camera videos last time. And the biggest reason is that in physics, that's exactly what physicists do. They observe a natural phenomenon, and then they try to figure out why that is, and they make guesses, and then they test those guesses. And depending on what the results are, that means that they're either could be right or that their idea was wrong. And so then they create some more tests and then they go from there. Then we talked about what is velocity and acceleration. These are some of the things that students came up with in the various different classes. So when talking about what is velocity, velocity is going to be basically how fast something's going and which direction it's moving in. So they came up with velocity is how fast an object is going in a certain direction, the speed of an object, how fast this should say an object is going. An object's speed and direction in motion, speed in a certain direction. And then we were talking about acceleration. So acceleration is an increase in the rate of speed of something over time. So that would be, like speeding up or slowing down. So an increase in speed over time, how quickly you speed up or slow down, the rate at which your velocity changes. Acceleration is a rate at which an object changes its velocity. So all of this is about like how quickly you can speed up or slow down. Alrighty, so then we also did some observations. So I had the students watch me do. All right, so I did a lab and had the students watch me do it and run these little cars around on the floor. And you'll be able to see what those look like when you watch the videos to collect your data. And they made some observations about the cars. So they said the cars stayed at the same speed almost the whole time. The cars accelerated really fast, but they slowed down and stopped when they hit something. The blue car slowly started to catch up to the red car. It looked like after a while they started to slow down. It stopped once it hit something. I assume that's the car. The car accelerated, speeding up, slowing down, or changing directions. The cars were going the same speed. The blue car had a slower velocity than the red car. The red car accelerates faster than the blue car. The blue car doesn't accelerate as fast as the red car. And some people thought it was constant velocity. So there was this discrepancy between in our discussions during class of some students saying that they thought the cars kept going at the same speed the whole time, and other people said no, they were speeding up or they were slowing down. So that's what we decided to investigate. So we wanted to know, was the car going the same speed the whole time or not? And then we talked about, well, how do you measure how fast something is going? Because if we need to know if it's going the same speed the whole time, we also need to know how fast it's going at some point or another in general. So the three most common answers were that you measure the distance and the time it took to travel that distance, or you measure how much time it takes to go a certain distance, for example, like 100 feet. And then you could pick times and see how far the car went. So those are the three most common. And then this is the video document. So if you click on this, you'll go to this link, which is where I where I have all of the videos linked. And unfortunately, it's not going to let me show it to you right now. So I've copied it. So I'll just show you what it looks like. So this is what what that document looks like. So you have each of the different cars that I've run for different trials. So there was a red car, and then there's the same red car, but I did it 2 different ways. So the first way I did it time independent. So I tried to slow down like the movement of the camera at 0, 2, 4, 6, 8 seconds to make it easier to read the meter stick. And then for these ones for distance, what I did is I slowed the movement of the camera down at the 1 meter mark and the 2 meter mark and the 3 meter mark, so it was easier to collect data. And then I did the same thing with a blue car, which travels at a slightly different speed, so you'll get different data. Each student only needs to pick 1 trial. So you're going to pick 1 trial and you are going to collect the data for that trial. And then the third option, there's a second red car. This is the red car with passengers in it. They're little cute paper passengers that some of my students created a few years ago. And then 6th period had me do it a little bit differently. They had me put a stopwatch in the video itself. So I have that one as well. So this is what is in that other document. And then there is an example data table here. Okay. So let's talk about that example data table. So this is everything so far that we did during class. And then for your distance learning, what you'll need to do is watch one of those videos and create a data table of your data from that video. So here's your procedure. You're going to, and then I also had the students write a procedure so that way I could create those videos that I just showed you. So the procedure that I chose to have all of you use is I started the stopwatch, started the video, and I turned on the car. Then I placed the car before the 0 mark, record the time when the car is at 0, and then it recorded the timestamp when the car was at each meter, and then complete the data table below. So here's your distance and time, and then what this means, the time driving past 0 meters, is that in the video, the car passes the 0 meter mark at some time other than 0. So what I want to do is essentially fix the data so that way it is 0 here. So the way you do that is in this example, the car passed 0 at 2 seconds. So then I just subtract 2 from every single one of these times, and that will be how long it's been driving since it passed the 0 meter mark. If you have any questions, let me know. I also try to explain that here. Otherwise, good luck with your lab.